Hello and welcome to this PAC CXP Group webinar, where we'll be discussing the topic of digital transformation in the manufacturing industry. I'm Sarah Wilson and I'll be moderating today's webinar. I'm joined by Research Director Stefanie Naujoks, who will be your host for today. If you have any questions during the webinar, please use the chat function and we'll spend some time at the end answering as many of your questions as possible. So without further ado, I'll pass you to Stefanie to start the webinar.
Okay, thank you very much, Sarah, for the introduction. And what you will hear today in this webinar is, so first I will give you an overview about what kind of goals of digital transformation projects manufacturers have and what their maturity is in terms of digital transformation strategy. Then I will also talk a little bit about the challenges that manufacturers report in the digital transformation context. And I will give you an overview about which technologies manufacturers consider as relevant for their digital transformation. And we will look at a bit more closely into how our technologies can support digital transformation and some use cases in various manufacturing domains. And we will close this webinar with some recommendations for manufacturing companies as well as for IT services providers. So, in order to understand why digital transformation is an important topic for manufacturers today, I want to share with you the three major challenges which manufacturers are facing today. And these are reaching new customer groups and revenue areas, reducing costs and efficiency pressure, and increased competition. And one way for manufacturers to address these challenges is to digitally transform the way how they do business and how they operate. So we've also asked manufacturers about their goals of digital transformation. And these are the top 5 goals of digital transformation. So optimizing internal processes, improving the digital customer experience, creating new digital business models and positioning, establishing an agile and innovative organization and culture, and also establishing new value networks and digital ecosystems. So having talked about the goals of digital transformation, let's now have a look at where manufacturers are in terms of digital transformation. And here our survey showed that 37% of manufacturers do execute individual digital IoT projects in selected business areas, but do not have a company-wide strategy yet. And 35% execute a company-wide digital IoT strategies for the entire enterprise. But interestingly, there is still quite a high number of manufacturers, or high share of manufacturers, 27%, that haven't discussed digital transformation internally at all, or that are still in the planning and discussion stage. So having said this, what are the major challenges or barriers which we see around digital transformation? And actually, whenever I talk to CXOs of manufacturing companies and ask them whether and how they are engaging in digital transformation initiatives, most of the time the discussion is sooner or later drifting towards the reasons why digital transformation projects are challenging. And basically the top reasons which I tend to hear most of the times are, well, our people don't have the right mindset, they don't see the need for digitally transforming our processes, and this includes upper and lower management, but also normal team members, right? And then secondly, there often is a perceived lack of innovation culture in the company, and also very often I hear that it's challenging to come up with a business case, meaning to have identified potential use cases, and also have managed to build a business case around this. So, for example, manufacturers report that they have potentially masses of data, but they simply don't know how to monetize on this data. Then what I also hear often is that it's challenging to determine which organizational structure works best and where to best embed the digital initiatives in the organization of a company. And last but not least, having only the traditional legacy KPIs which relate to revenues or costs also prevent from establishing an innovative company culture or to change people's mindset toward the importance of digital transformation and innovation. So these are the major constraints I tend to hear when talking to manufacturers about digital transformation. And what I don't hear is there is a lack of appropriate technologies, right? But clearly, and I don't want to get me wrong here, so technologies of course do matter, And those manufacturers that underestimate the potentials of technologies, like, for example, IoT, artificial intelligence, robotics, augmented reality, 3D printing, and you name it, for their business and operations, will be overrun by those who don't. And looking at all these new technologies that are out there, we've also asked manufacturing companies about which technologies they consider as being relevant for them. And the large majority of manufacturers consider all of these technologies, you can see on that slide, as being quite relevant for them. So the main message here is that if you're a manufacturing company, make sure that you also look into the potential which these technologies can bring for your business. And the big question now is how technologies like augmented reality, 3D printing, robotics, IoT, cognitive artificial intelligence or blockchain can support digital transformation. And in the following slides, I will show some selected use cases of how these new technologies can support digital transformation in various manufacturing domains. So for example, in R&D, in engineering, production, logistics, sales, marketing, or maintenance and field service. And this will of course not be a complete list, but it will give you a brief overview. So what are use cases in R&D and engineering? And the two technologies I took here just as an example, right, are virtual reality and additive manufacturing. And these two technologies can, for example, help to shorten the cycles of new product development. And for example, leveraging virtual reality in R&D helps to increase the efficiency of product development processes in the ideation phase or in the early stage design of new products and assets. And it can help engineers to get a first impression about a new product prior to having a real physical product. And it also helps them to check products virtually from an ergonomic standpoint. And new products can also be tested virtually rather than producing a physical prototype, which would take longer and would be much more expensive. And what virtual reality is being used since many years, in particular in the automotive industry and in other manufacturing domains that have a high share of engineering work and tasks. So I don't want to bore you too much with virtual reality in engineering and R&D, as this is not really a new topic, right? But what I want you to keep in mind is that the more affordable virtual reality appliances like head-mounted displays also get, and we expect that this is well underway, make sure that you also evaluate the potential of virtual reality for your R&D and engineering processes, as these have quite some potential to speed up R&D processes like testing and prototyping. And looking at additive manufacturing or 3D printing, this also will increasingly play a role in the R&D domain of manufacturers. And this is not only because prototypes can potentially be built faster and comparably cheaper. These new additive manufacturing technologies are in particular interesting as they allow to produce products or components with optimized designs and new functionalities. So one major advantage of additive manufacturing is that it allows objects to be designed and produced in such a way that both material usage and consumption can be minimized. This enables the production of lightweight parts, which is particularly important for the aerospace industry, yet where you'll find, for example, Airbus being a very early user of additive manufacturing technologies. But also companies like ThyssenKrupp see major advantages in additive manufacturing. And here, for example, the CTO of ThyssenKrupp said that with 3D printing, they can focus fully on the design itself without having to factor in the restriction imposed by conventional manufacturing processes, which basically opens up completely new potential for innovation. And actually, the more manufacturers will look into additive manufacturing technologies, it comes with no surprise that increasingly IT providers coming from the engineering application domain like Dassault Systems or Siemens have announced plans to offer marketplaces for 3D printing services and parts. So we now looked at the R&D and engineering domain of manufacturers. And what about the shop floor? How can technology support digital transformation here? So, as one of our survey results showed earlier, a key goal of digital transformation for manufacturers is to optimize internal processes. And optimizing processes also often comes along with further automating processes. And looking specifically at shop floor operations, technologies like robotics, IoT, and artificial intelligence will in particular be key components to further automate processes on the shop floor. And leveraging these technologies will enable what we call next generation automation on the shop floor, which will be based on smart robots. And such smart robots will have artificial intelligence embedded and will also be connected via industrial IoT platforms. This will open completely new eras of automation on the shop floor because such smart and connected robots will then be able to make autonomous decisions on next best actions to be taken, for example, at an assembly line. And ideally, this happens all in real time, which is why edge computing or edge analytics capabilities will also be of growing importance. And of course, and I will not go into details here in this webinar, but in order for smart robots to make autonomous decisions, data from the enterprise application layer needs to be available and analyzed, and which requires an appropriate vertical integration of the shop floor with the enterprise applications. But anyhow, furthermore, we will also see increasingly cobots on the shop floor. Which are, and these are actually smart robots that are able to work together with humans collaboratively, also leveraging AI, sensors, or camera systems. An interesting use case on the shop floor is also that smart robots can also be applied for the automation of warehouse processes. And one of our latest surveys showed that manufacturing companies rate the value of leveraging AI for robots that are picking orders and moving them inside warehouses are quite high, or they rate that as quite high. In fact, 70% of all respondents said that AI will provide a great value contribution here. And interestingly, ZF, who in the past only produced gearboxes for forklifts, has announced its ZF Innovation Forklift at this year's Hanover Fair. And this is an automated electric and networked smart forklift, which is equipped with a camera and a radar system that enable it to see its surrounding environment. And it also leverages AI to ensure safe operations by avoiding accidents on the factory floor. So we are now leading the shop floor towards the supply chain and how technologies can support digital transformation here. And generally speaking, technologies like IoT, cognitive analytics, and artificial intelligence, and also blockchain will enable supply chains to become smart. And why does the supply chain have to become smart? Well, so basically, the goals of further optimizing supply chains today are still very much related to the ever-important goals of driving down inventory costs and at the same time avoiding that things run out of stock, reducing supply chain costs, and minimizing risks and incidents in the supply chain. But there is one new goal of supply chain optimization today, and this relates to increasing the overall customer experience. This is because one major lever for improving customer experience is the ability to delivering products faster or making the delivery process more transparent to customers. This is a result of end-user customers which have increasingly become used to Amazon's speed of delivery or DHL's track and trace functionalities. And this now also increasingly applies for B2B customers. So to address the traditional challenges of supply chain management, as well as the new challenges, supply chains will have to become smart in order to support these new dimensions of speed and transparency in the supply chain. And I would like to share with you one more survey result in this context, which is that 46% of manufacturers consider improving supply chain management as a major driver for investments in IoT. And like mentioned earlier, automation of processes will become major important for manufacturers, and the same applies for the automation of B2B transactions in the supply chain. And the greater the maturity of robotics and robotic process automation technologies, the more this will enable further automation of supply chain processes. And when talking about automation of supply chain processes, so I'm thinking, for example, about automatic replenishment processes, blockchain and smart contracts will help to automate these B2B transactions in the supply chain by providing authentication and validation of B2B transactions in a broader ecosystem. And now let's look at how new technologies can support service and support processes. And basically, augmented reality and IoT can help to reduce costs of services and increase quality of service. So first of all, IoT enables OEMs to reduce unplanned downtime of machinery at their customer site. And how? Well, if machines are connected and deliver data to the OEM can monitor the performance of a product and take immediate actions in case the analysis of data shows that it is likely that a machine will soon have a problem. And I also wanted to share with you one of our survey results, which shows that improving asset servitization with predictive maintenance concepts is a major goal of IoT investments for half of all manufacturers surveyed. And IoT and augmented reality can also help to increase efficiency of service processes. So, for example, one use case is that a service technician is equipped with a mobile device and gets service instructions displayed as a second graphical layer above the physical product which needs to be repaired. This increases efficiency of service tasks, as the technician, for example, doesn't have to look at paper instruction and how to repair products in paper-based service manuals or documentations. The time it takes to repair a product can be reduced and the quality of service increases, which overall helps to increase customer experience again, and also, of course, lowers cost of service. And by leveraging IoT, this can also help to minimize the need for on-site service calls in general. So, for example, if you have products on site at the customer, which are equipped with sensors and connected via IoT and deliver performance data to the OEM, then ideally the OEM can monitor the performance of a product and send alerts to the customer so that he can take immediate action and ideally avoids any service calls. And in case service is needed, rather than sending a service technician on site, the OEM can assist the customer actually on site, solving a service issue, leveraging augmented reality solutions, which display service instructions, just like described above. And last but not least, augmented reality and actually also virtual reality help to overcome lack of skilled service technicians. So, for example, manufacturers increasingly report a shortage of adequately trained service technicians. Think about complex plants like in the chemical industry or oil rigs. So here, augmented reality and virtual reality can be used to support lower qualified service technicians with a direct connection to a specialist service technician at the OEM. And for example, Linde is using smart glasses that allow a remote connection with a Linde expert to manage troubleshooting and maintenance situations while walking around the actual plant. And now let's look into how new technologies can support sales and after-sales processes. So first of all, IoT, cognitive analytics, and artificial intelligence enable the analysis of data from smart and connected products in order to increase sales and after sales. This is because if you know how a product is behaving in operations, meaning while the customer is using your product, you can offer add-on products or services if your product is equipped with sensors and if your customer actually has agreed that the product delivers operating data to the OEM, to you basically. And I have an example here for you, which is about Coca-Cola. And they are, for example, connecting their fleet of cold drink equipment, like, for example, their coolers and vending machines in retail stores to track product inventory and monitor energy efficiency, among others, which with the goal to drive drink sales, leveraging, for example, artificial intelligence. And a recent survey showed that 3/4 of manufacturers, so 75%, stated that AI delivers great value, basically to decide upon the best strategy based on the actual situation on site. So applying artificial intelligence can help to better predict customer demand and automate targeted offerings. And now I'm coming to my last slide about use cases, and which is a particularly interesting topic because it spans across all domains. So for example, from design to engineering to production, operations and maintenance. And this is basically about the digital twin. which is a concept which leverages in particular IoT to enrich a virtual model with physical product data from engineering, from production, from the supply chain, and from operations in the field. And basically, the digital twin concept is nothing new. But it definitely has gained traction over the recent months due to the increased maturity of IoT solutions and platforms, which are a means of gaining more and more data from connected products and objects, and in turn enriching the digital twin. And the more the digital twin is enriched with data, the more it can serve as the basis for further product and process optimizations, and in particular innovations. And digital twins can be used, for example, to reduce the costs of expensive prototyping and product development by simulating the behavior of the products with appropriate software tools. And the digital twin of a product also enables virtual commissioning for production, thereby accelerating the handover process from product development to physical production. And if a digital twin is enriched with performance data from an actual product in operation, for example, at the customer site, product engineers can use this data and further optimize their products using real-time operational data and product simulations. And furthermore, additional services such as predictive maintenance can be proposed when the digital twin, as a result of data analysis, identifies when it would be useful to carry out a service inspection on a machine on the customer site. So having a full digital twin also allows OEMs to offer new business models, like, for example, products as a service, where the OEM does not sell machines, but output. So, for example, a certain number of bottled beer rather than bottling machines. And one of our recent surveys shows that already over 1/3 of manufacturing companies in Europe consider themselves actually as being strongly versed with the concept of the digital twin. So, we now looked at some use cases of how technologies support digital transformation of manufacturing companies. And just to be clear here, we were only looking at some of the new technologies out there. There are, of course, certainly many, many more ways to address digital transformation of manufacturers' processes. So, for example, by also leveraging software applications and platforms that exist for all of the domains which I was touching upon, like modern ERP applications or PLM or MES applications and platforms. And all of these use cases mentioned were, of course, very generic use cases and only some very high-level examples. Of course, there will be much more specific use cases depending which subsegment in the manufacturing industry you are looking at, or which company, in fact. But as we said at the beginning, digital transformation projects often fail due to a lack of commitment from people, responsibilities, innovation culture, and a lack of business cases. Our recommendations on how to approach digital transformation projects are as follows. So, first of all, think about a concrete problem which you want to solve. This can be on the shop floor, in the warehouse, in your field service organization, or the way you develop your products. And then second, elaborate on how new technologies like IoT, augmented reality, 3D printing, or robotics can help to solve this problem. And third, develop a business case for this concrete problem, but start with a small project to receive business results and an ROI soon. And then, that's actually the most important part, communicate project successes and results, and in particular the ROI internally, as fast as possible to increase transparency and to win management as advocates for further projects. This is also important to motivate team members and potential followers to initiate further projects. And what are my recommendations for IT vendors? So, IT investment decisions are shifting more and more from IT departments to the lines of businesses. So IT vendors need to make sure that their business development is moving target roles from IT to business executives. Then secondly, discuss business objectives rather than IT solutions, and help manufacturers to identify use cases that are applicable for solving concrete problems and apply new but mature technologies. And then articulate IT solution benefits in terms of manufacturers' end users, so the end user customers, as increasing customer experience is a major goal. So never forget about the customer in discussions with your customers. And then also engaging conversations about customer experience strategies. So as well as data-driven product and service innovations, as the challenges, or a major challenge for manufacturing companies is about how to monetize on data. And then last but not least, be open-minded towards adjacent industries, as business ecosystem strategies will play a major role for creating new business models. So we are at the end of my presentation, and on that slide, I quickly wanted to share with you some of the sources which I was referring to during my presentation. And please also allow me to do a little sales pitch for our manufacturing research program, which we'll be more than happy to introduce you to in follow-up discussions. And now, I think, Sarah, we still have some time for Q&As, and I'm ready now to take some of your questions.
Yes, thank you, Stefanie. So the first question I have for you is, you mentioned that companies will need new KPIs to run digital transformation initiatives successfully. What kind of KPIs are you thinking about?
Yeah, so well, thanks for this question. And first of all, for sure, there will be KPIs that cannot be changed. Like, for example, in a production environment, there will have to be KPIs for the head of production, which are based on hard facts, right, in order to ensure both efficient and smooth shop floor operations. And for sure, the head of sales will also be measured against revenue targets in the future. But what if the head of production and the head of sales get some additional KPIs? So which are, for example, targeted towards a more customer-centric approach, or targeted to enable more innovative thinking in a company. So, for example, what speaks against implementing KPIs that are related to a certain number of cross-domain meetings where the head of sales and the head of production participates, as well as someone from the CIO organization. And what if they have a joint goal basically to brainstorm about innovations and what is necessary to implement them? So I believe that having such cross-domain meetings can help to create a culture of innovation, but that's of course just one idea. And if I think about some further KPIs, maybe there could also be a KPI, for example, that encourages your field service personnel to give feedback about customer issues which they observe, right? But this is not really a new initiative. This exists in companies for quite a while. But it's so important for companies who are trying to motivate their employees and to report any suggestions related to improvements or innovations. So I know that that's not brand new, but it cannot be underestimated. It's so new, so it's not so new. It's so important, because in order to make digital transformation initiatives a success, this really needs to be tackled from all sorts of angles, and I believe really that having appropriate KPIs that are enabling or supporting digital transformation is just one possible approach to address this challenge, basically. Just hope this answers the question.
Thank you for your answer there, Stefanie. So the next question I have for you is, you talked a lot about use cases and only to a lesser extent gave also some examples of different companies. Can you give some more examples of companies that engage or have engaged successfully in digital transformation initiatives?
Yes, so I totally agree that giving examples of companies helps to better understand use cases, and for sure examples are always helpful, especially for me as an analyst. Examples are very interesting for me to follow in the market and to look for in the market. However, on one hand, there are use cases which are only at the very early stage, with only a few companies piloting or experimenting with it. And on the other hand, there are other use cases where more companies are already made experience with, for sure. So I tried just to mention some examples, but for sure there are many more out there, and I'll be happy for follow-up discussions and joint discussions on that. The thing is, we have a tight schedule for this webinar, and I wanted to keep this kind of short. So what I can do is to refer you to our innovation database, which is a database where we gather and collect IoT and digital related projects and initiatives. And this database, in fact, I'm thinking about the exact name. I think that's our PAC Innovation Register. We actually have an impressive number of, I don't remember the exact number, but I estimated something like about 600 or so real-life best practices related to IoT and digital initiatives, and there are probably like over 250, probably almost 300 examples coming coming from the manufacturing industry. So yeah, so I definitely refer you to our innovation register, which is available on the website. So there are lots and lots of kind of exciting or interesting examples of initiatives. Yeah, hope that answered the question.
Yes, thank you, Stephanie, and thanks to everyone today for listening. That's actually all the time we have for today, but we'll make the slides and recording available, and we'll send you an email so you can download them. So if you do have any questions in the meantime, please do get in touch with me or Stephanie.
Thank you very much.